Okay, we're going to talk about scientific notations and using powers of 10 to express really, really big or really, really small numbers. And I want to start out with the speed of light. The speed of light in a vacuum is expressed as 299,700,000. So it's basically, if we're going to round it, 300 million meters per second. I wouldn't remember that, but I do remember that it's 3 times 10 to the eighth. That means power of 8 meters per second. And I always remember that because that is the best approximation of the speed of light. 3 times 10 to the eighth meters per second. This big, huge number can be expressed as a power of 10. And that's really, really useful not only for remembering things, but for expressing things that are super, super huge or super, super tiny. So basically, scientific notation is when we take in the form of a number, or a number with a decimal, times a power of 10, 10 to the power of something. So they can either be positive, so that number is going to be 1 inclusive up to but not equal to 10, 9.9 whatever, or it's going to be negative. It's going to be approaching 10, but it's going to be less than or equal to -1. Whereas m, which is that little power, that has to be an integer, which is another way to say is a whole number, like a whole number. So large numbers like 38 million years, that's a long time. What we'll do is we will express that as a power of 10. We'll take the first non-zero number, put a decimal after it, and then we will write 10 to the power of whatever it would take to bring us back to that original number. Small numbers are the same. Small numbers, nanoseconds, 417 nanoseconds. What does that really mean? Well, that's 0.417 seconds. And a cleaner way, which still has the same meaning, is because we're going negative, our negative numbers, like our negative indices, interesting, multiplying by that is like dividing by that amount. So we take our first non-zero number, 4, put a decimal after it, and we keep the other numbers, but essentially we're saying, all right, I'm going to go back 7, I'm going to divide by 10 to the power of 7, or go back 7 jumps and express that this way, still makes the same thing. Place the decimal point after the first non-zero digit, then we go by our powers of 10. So there's a lot of fancy names. What we mostly use is kilos. So if we want to change something into kilos, we're looking at 1,000, 10 to the power of 3. If we want milligrams, then we're going to divide by 1,000. So this is just fancy ways of doing the things that we've done for a long time. Mega, giga, are all powers of 10, how we're going to go from one unit to the next. So some examples, I gave you the speed of light. 2,178 kilometers in meters can be expressed like this: 2.178 times 10 to the 6 meters. Gigabytes is this whole big number, or it's 1.6 times 10 to the 10. And if we're going smaller, microns, 27 microns looks like this in meters, or 2.7 times 10 to the -5, or divided by 10 to the 5. And if you ever needed to know the billionth of a second for a quiz anywhere, oh boy, it's 5.4 times 10 to the -8, so it's going backwards. Let's do some examples. So we're going to write these numbers in scientific notation. So I have 4,500,000. And so what I want to do is I want to put my first non-zero digit, which is 4, 0.5, and then I want to figure out, because this is a big number, so how can I take the little usable number like that, 4.5, and bring it back? If I had 4.5, what would I have to do? I would have to move my decimal place 1, 2, 3, 4, 5, 6 places to bring it back to 4,500,000. So that means I'm going to have 4.5 times 10 to the 6th will bring me back to that original number, and in essence represents exactly the same number. In this case, I've got all those zeros, and I'm going to imagine that I have my decimal point there. So that'll give me 4 times, and really how do I divide? Well, I do 10 to the negative. So how many jumps will bring me back to this huge number? I place my decimal place there after the first non-zero digit. 1, 2, 3, 4, 5, 6, 7. So because we're going backwards, 4 times 10 to the -7 will deliver that result. Now we're going to go back to decimal form. So if I have 9.34 times 10 to the 5, that 10 to the 5 just means that I'm going to do my jumps in that direction, +5 to the right. 1, 2, 3, 4, 5. Therefore, This is 934,000. That's the way to express that number without using scientific notation, or to bring it back to decimal form. In this case, we've got a negative number, so we're going to take our 4.71 and we're going to jump backwards. 5. 1, 2, 3, 4, 5. And I'm going to place my decimal there, so therefore we have 0.40471, and that is how you express that number back in decimal form.